Bismillahirrahmanirrahim. Assalamu alaikum dear students. How are you all? Hope you all are fine, safe and sound at your home. So as you know that Zoom classes have been started again. So today I am going to deliver the lecture on the topic of unit number 1, that is significant figure. Now the question is that what are significant figure? Significant digits are certain digits that have significance or meaning and give more precise details about the value of the number. So, explanation: there are two types of values. One is the exact value and the other is the measured value. Exact values are those values that are counted clearly. For example, while reporting 3 pencils or 2 books, we can indicate the exact number of these items. On the other hand, values associated with measurements of any kind are uncertain to some extent. For example, if we want to measure the length of a pencil with an ordinary meter ruler having least count of 1 millimeter, we note that the length of a pencil is greater than 67 millimeter and less than 68 millimeter. We can estimate that the length of pencil is 67.5 millimeter. The length is accurate up to 67 millimeter, accurately known number, that is 67, but the last fraction has been guessed. So there is a chance of error in last figure and it is known as the doubtful figure. So in this value 67.5 millimeter, the 67 is the exact accurate value and 5 is the doubtful figure. Now on the basis of this example, we can define significant figure that the number of accurately known figure and the first doubtful figure are known as significant figures. Now we have some general rules for writing the significant figures. One by one we proceed. First we have rule number 1. In rule number 1 we have that all non-zero digits. Non-zero means which is not zero. So we can say that 1 to 9 are numbers are called the non-zero digits. So the non-zero digits are always significant, that is all the digits from 1 to 9 are significant. For example, if we have a number that is 47.73, so in this value there are 4 significant figures because 4, 7, 3, these are all the non-zero digits. In these examples 456, so it is also there is no non-zero digit, or all the digits are non-zero, 4, 5 and 6, so it has 3 significant digits. In 68.29, so all the digits are non-zero, there is no zero in these two values, so it has 4 significant digits. In first value 4, 5, 6, so it has 3 significant digits, and in second value 68.29, it has 4 significant digits. Now come to the rule number 2. In rule number 2, the zero in between the two significant digits or non-zero digits, it's always significant. For example, if we have a value 32.50063, so the zero is in between 5 and 6. So 5 and 6 are the non-zero digits. So these 0 are significant. So in this value, if we count the values, so there are 7 significant figures from 3 up to the last 3. Other examples of rule number 2. In this example, we have 5609. So, in this value, 0 is between 6 and 9. So, in this value, it has 4 significant digits, that is 5, 6, 0 and 9. In the second example, 700.0879. In this value, 0 is also again in between 7 and 8, and the 7 and 8 are the non-zero digits. So, if you count the values, so there are 7 significant digits. So, rule number 2 is clarified that 0 between the non-zero digits are always significant. Now we have rule number 3. In rule number 3, we study that the 0 to the left of a significant figure are not significant. For example, in value 0.00467, so the 0 which are before 4, so they are not significant. So there are only 3 significant figures, that are 4, 6 and 7, and the 3 zeros which are before 4, these are ignored. In other examples of rule number 3, we have in this slide, in first value, which is 0.067. So here are 2 significant digits, that is 6 and 7, and the 0 before 6, it is ignored. In the second example, 0.000008, it has only one significant digit, that is 8, and all the other 0, they are not significant. The last example, 098, so it has also 2 significant digits, that is 9 and 8, and the 0 before 9, it is not significant. So it is proved that the 0 before the non-zero digits on the left side, so they are not significant. Now we come to rule number 4. The 0 behind the non-zero digits are sometimes significant. So we have 2 cases in rule number 4. Now we come to case number 1. In case number 1, we study that when there is no decimal, the 0 behind the non-zero digits are not significant. For example, in 4000, it has only one significant figure, that is 4. All the 0 that are after the 4, they are not significant because this value has no decimal, and the 0 are behind the non-zero digit. Similarly, in 82,700,000, it has also 3 significant figures, that are 8, 2 and 7, and all the zeros, they are behind the non-zero digits, so they are not significant. In the last example, 341,600, it has 4 significant figures, that are 3, 4, 1 and 6, and the last 2 zeros, they are behind the non-zero digits, so they are not significant. So it is the case number 1, when there is no decimal in the value. Now we come to case number 2, when there is a decimal fraction and 0 behind the non-zero digits. So in this case, these 0 are significant. For example, in first case, 894.00, so they have 5 significant digits because it is the decimal fraction and the 0 are behind the non-zero digits. So there are 5 significant digits, the 2, 0 and 8, 9 and 4. Now in 0.0090, it has 2 significant digits, 9 and 0. The 3 before the 9, they are not significant. In third example, 7.0090, they have 5 significant digits, 7, 0, 0, 9 and 0, because the 0 which are after 7, they are between the two non-zero digits, that are 7 and 9, and the last 0 is behind the non-zero digit, that is 9. So it has 5 significant digits. So when there is a decimal fraction, the 0 behind the non-zero digits always will be significant. It was our rule number 4. Now we come to the rule number 5. In scientific notation, if we have any value which have the standard form or have the scientific notation, so the figures other than power of 10 are all significant. It means that we have the formula for the scientific notation n equals to m multiplied 10 power n. So the 10 power n, it is not significant, but the mantissa always be significant. So in this example, 9.11 into 10 raised to power minus 31 kilogram. So the 9.11 is significant and all the other values are not significant, because 9.11 is the mantissa, so it is always significant. So it has 3 significant figures. So at last we come to the summary of these rules of significant figure. That first rule is every non-zero digit is significant, that 1 to 9 digits are significant. Number 2 is 0 between the two non-zero digits, they are always significant. For example, 909, 909. So it has 3 significant digits. Third point, 0 before are never significant. If the 0 are before the non-zero values, so they will not be significant. When there is no decimal, 0 behind the non-zero digits are not significant, and when there is a decimal, 0 behind the non-zero digits are significant. I hope that it all clear to you. Till the next class, Allah Hafiz.